Hello, Drew here with a lecture video on Matlab. Matlab is just a big calculator that we have on our computers here, and you can access it just by going Start Menu, Programs, Matlab. Oh, and let me say I'm a little further away from the microphone, so if you can't hear me, just boost your volume up, and there shouldn't be any problems there. So to start with, we have the main Matlab window. It'll take a little while to boot up for you if you want to come along. So I'll go over this while it's starting. We've got your typical menu bar up here. Some nice handy buttons that you can customize. The path where Matlab is currently looking, and that also appears over here in the current folder. Current folder is pretty important, kind of defines your work area. You can see there's some .m files. Those are basically functions or little programs that people have written for Matlab, and you can write your own. It's very easy. Here we have our workspace. The workspace is where your variables will appear, and then here's the command history. And the command window is the big part right here. So when it's ready, you'll have the double arrows here. The lecture notes, if you look through them, mention Scilab. The commands between Matlab and Scilab are very similar. I don't think it's 100%, but functioning knowledge of one will get you pretty far in the other. So let's start. In the notes, we're looking at a sinusoidal signal with time as our domain, and we can define that just by typing in what we've got in the notes. So I'll start off here. The square brackets define a matrix. In newer versions of Matlab, you don't actually need those. You can just define it like this even. Same exact thing, doesn't really matter. Our function is a DC value of 3 plus 4 times sine of 10t plus 2 times cosine of 50t. Now these asterisks, multiplication, those are necessary. What I'm going to do at the end of this before I hit enter is put a semicolon. That suppresses the output. So I do that, and it just shows up over here in the workspace. If I hadn't, go back, and we get all the values for it. Not really useful, but if you wanted to check something in the middle, this is the way you do it. Just omit that semicolon. So anyway, continuing on. We can plot it just by using the plot function. This is a basic Matlab function. All we do is ty. As you might have seen, the Matlab help pops up there, and it shows you, okay, if we just plot y, let's try that. What do we get? Okay, we get something that looks like two sinusoids added together, and then on the abscissa, all we have is the point number, so the sample number. So at sample 50, this is what the value is. If we want to go back, put it in terms of time, we just put that in front of it, hit enter again, plot it. Now it's in terms of time rather than the sample number. So you saw before it went from 0 to 301. Of course, that's how many samples we have, 301. Alright, so let's do something to the signal. First we take the derivative. And here we define our first derivative as dy, and we're going to initialize it, so it's 0 times y. 0 times y. So we just kind of have this empty vector, this empty array, that we can manipulate now. And we do this to save computation time. It's just a good habit to get into when you start writing your own programs for it. To start off with, in the notes, we have numerical differentiation. For this video, right now I'm going to do the quick way. The quick way is we type diff of our signal. So here again we get the pop-up that says diff of x. These are the arguments you can put into it. You can give it the number of points, you can give it the dimension you want it to differentiate over. For now, I'm just going to take y. So press the output, hit enter, and it appears in ANS, answer. So this is the last thing that we typed in. Well, I don't like that. I want to be able to manipulate it a bit more, and I don't want it to get overwritten, so I'll redefine it. dy equals diff of y. Okay, so now I have dy. Let's plot it. T dy, we're going to get an error. See, already we know that when we differentiate this, we're going to lose the point on the end of that because we have to take the difference between 2 points. So let's lose one of the points on the end. So we have 300 here, whereas our time vector is 301. So all I have to do is go back in here. And what I've done here is just create a little matrix for this dy. So I'm just tacking a 0 onto the end. Plot it. Now 0 doesn't make a big difference at all. You can put it at the beginning, you can put it at the end, doesn't matter. But we get the differential of the circuit. However, you probably notice a problem. The values are wrong. And the reason for that is what we have is dy. And what we want is dy dt. So, all we have to do is come back here, and are we going to multiply, or are we going to add? Well, let's figure it out. Well, our dt, remember from up here, was 0.01. If we multiply, it's going to get smaller. That's not going to be right. You can check that by going back, plotting, looking at it. Yeah, that's way wrong. Okay. So simple guess and check, even if you had no idea how to differentiate, you can say, okay, we need to divide. And that makes sense, right? Because dy per dt, dy over dt. So we have dy up here over dt down here. And let's plot one more time. Voila, exactly what we have in the lecture notes. Okay, so let's integrate now. Again, in the notes we have numerical integration. I'll show you the easy way. So if we wanted to integrate in Matlab, there's a couple methods. You could use the trapz function, trpz. For now, I'm going to leave that alone. That's kind of a more advanced thing. For our purposes here, just for this numerical integration, all we need to do is cum sum, cumulative sum. And all we have to do is take a y. So big Y, integrated y equals cumulative sum of y. We can plot it versus time. Go to our figure. Okay, so it looks really big. Of course, you probably see the same mistake we made last time. We need to multiply. Go back to plot. There we go. So as you can see here, with having to add these DTs in here, Matlab isn't going to take care of everything for you. You need to put a little bit of thought into it. You need to know how integration works, you need to know what the form of it takes. Otherwise, your answers are going to be off by some factor of that DT. So just be careful of that. The next big thing you can do in Matlab is make a program. And this is really easy. You can make your own functions, you can get really advanced with it. But for now, if you just go up to here, you can press this, new script, file new script, or you can just hit Control-N, pops up with this window. And this is the editor window. And you can see I've already got one here, already laid out. So I wrote this up, and it's exactly what we just did, a little more fancy. And let's just go through this real quick. So first off, percentage sign is the comment. So if I want to comment, I can hit Control-R and it adds a percentage sign in front of the line. If I hit Control-T, it removes it. I can see back and forth. Remove, add, as you will. Double percentage sign starts a new cell. And what cells do, you can kind of see this different background here, this yellow background. And if I click through these, you'll notice I have here one label definitions, the cell is the time to main signal, differentiation, and integration. And the cells are important, especially when you're coding something really long. It's nice to see able to separate things out. But also, you can hit Control Enter just to execute that cell. And I believe that's in here somewhere. Nope. Okay, well, it's in here somewhere. Control Enter will just run that cell. F5 will run the whole thing. So let's just go through this line by line and then we'll execute it. So first off, I've got my title up here. I've got some fancy ASCII art up here, just for a demonstration of how this commenting works. And then I have these two commands, close all and clear all. Close all, do right here, is just going to close all of your figure windows. And I get two errors here. Don't worry about that. That's something that's specific to this machine. Clear all will kill everything inside my workspace. So clear all kills everything. If I said y equals 0, set it up real quick, and x equals 0, if I just want to clear y, all I have to do is hit clear y. So on and so forth. Real easy. Go back to our editor here. Okay, that's strange. If I hit Control Enter, it just executes that cell. If you want to execute just a line or what you have selected, highlight it and hit F9. So there I've hit F9. You can see it pop up in the command window. It showed up as close all. So here, now we go to definitions. I define my DT, and then I put my DT inside of this array for time, instead of defining it long form up here. That allows me to change my DT in the future. Wow, this is really wonky. Allows me to change my DT in the future without having to change this equation. Additionally, you can see now that I've got my cursor on DT, it highlights all the instances in the rest of this M file, this script. So I've got 2 here, I've got 2 here, I've got 1 down here, and it tells you that there's 6 usages that it found. So it keeps track of this, which is real nice. And having this DT defined allows me to use it later in the program. So I define it here, put it up there, hit Control Enter, just execute that cell, go down to the next cell, I'll hit Control Enter, and pop, there goes the figure. Here we have the same figure, I put some grid lines on it, and that command is just executed here. You can see the X label and the Y label for the 2 axes that I've defined here. All I have to do is just set it as a string. You could set it as a variable, so let's say S equals string, suppress it. If I put S in here, I would have the exact same thing. Doesn't matter, Matlab will handle it. It's smart enough to do that for us. So take those out. Next step, differentiation. Here, I've long-handed this with the numerical differentiation, and then I've done the diff. So I'm going to close this out first, and I'm going to do Control Enter just to do this cell, and I get what is called a subplot. And you can see in the code, subplot commands. The first one plots dy1, which is numerical differentiation, and the second subplot does dy2. The subplot tells me where these graphs are going to appear in the figure window. So this is a 2 by 1, so 2 rows, 1 column, and the first graph is going to be this code here. The second graph is going to be this code here. If I want to do like a 2 by 2, it would look something like this. I get a new figure, graph 1, graph 2, graph 3, graph 4, but since I just have 2, I left it as 2 by 1. And we can compare these. I put these in here just for visual sake. Exact same thing, doesn't really matter, as long as you remember to get your DTs in there. You do need X and Y labels for each one, and this command figure tells me to open up this figure window in a new figure window. So I had 1 plot up here, that's going to be my first one. My next one will be here, and then I did the same thing down here in the integration, where I've compared these two. So if I hit Control Enter, just to execute this cell, we get a brand new figure window with our integration on it. So now I have one for differentiation, one for integration. Comparing the two, again, you can see they're the same, no difference. So that's just the M file, just the notes. Let's go all the way through. So I'm going to hit F5, and F5 is just this button here. It'll save it and it'll run it, the whole entire thing. If I do that, it closes out everything, it cleared everything. Can't see it now, but it cleared everything, so it could rewrite it. And open up the first window, you can see is this plot. Second window is going to be our differentiation, and the third window is integration. Now if I wanted to, I can set specific numbers on these. So say I want figure 4 to be differentiation, figure 10 to be integration. If I hit F5 again, everything closes down, and voila. Figure 1, of course, is the first one. We just plotted it willy-nilly. Second one, figure 4, is our differentiation, and figure 10 is the integration, where I've set that number in there. And it will always appear in that figure 10. Not having that number there just says the next figure, a new figure. That's all for now, and we'll go over frequency responses and other techniques in a future video.